So reference angles. Up to this point, we've talked about our 30, 60, 90 triangle. We've talked about the 45, 45, 90 triangle. And we know how to find the different trig functions for that, correct? Then we talked about how to find the trig functions of certain points. Okay? At the points, you got your x value, your y value, and so on. Now, what happens if we're just given a random angle, so like 135 degrees? We don't know how long the thing is. We don't necessarily know exactly where it's at. We can figure out where that angle goes to. But how are we supposed to find the trig functions of an angle that doesn't fit into any of the triangles that we know about right now? Okay? That's where this thing called reference angle comes into play. So reference angle, let theta be a non-quadrantal angle. So it's not 90, 180, 270, 360. Okay, in standard position, the reference angle of theta is the acute angle, theta r, that the terminal side of theta makes with the x-axis. So we want to draw the angle and connect it to the x-axis and then find the angle that this triangle creates. So if we remember back to the beginning of this lesson, okay, the first thing we said was right here, when making angles in the coordinate plane, create your right triangles to the x-axis. That standardizes stuff for us. All right, so 135 degrees is the first one we have. We want to find the reference angle. So 135 degrees, what quadrant is that going to be in? 1, 2, 3, 4. 2. Be in 2. All right, we'd be in 2. Just think about it. 90, 180, right? It's between 180 and 90, so it would be in quadrant 2. So I'm going to go ahead and draw this guy. I think this is the easiest way to do it, is to draw it. So 135 degrees is going to get me over in here somewhere. All right, and I just kind of rough sketched it. It doesn't have to be perfect over here. Just make sure it's in the right quadrant, okay? So this is 135 degrees to get from here to here. Now, I need to make my triangle to the x-axis. So I'm going to drop it down to here, make a right angle. Now there's my right triangle. With that, I need to find my reference angle. My reference angle is going to be this angle here. So if it's 135 degrees to here, the x-axis is how many degrees? 180. So what is this angle going to be? 45. How'd you get that? Yeah, I just subtracted. So I'm going to have 180 minus 135, which is going to be 45 degrees. Boom. Now I can set up then from that, I can set up my 45, 45, 90 triangle to find my trig functions for that if I would need to. All right, right now we're just finding the reference angle. The big thing with this, I like to draw it so then I can see, do I have to subtract or do I have to add? Okay, you're going to have to make that decision a few times here. All right, let's go to number 2 here. Number 2 is 580. Now, remember back in earlier chapters, earlier sections, we want something to be from 0 to 360 when we're talking about degrees, correct? Is that between 0 and 360? No, so how do I standardize that? Whatever's left after 360, yeah, so let's subtract 360 off. What's 580 minus 360? 220? Now, is that between 0 and 360? Yeah, that just means I went around once, and then the whole way around, then I come around again. What quadrant would this be in? 3, correct. All right, so this guy's in quadrant 3. So 220 would be down here somewhere. Now this one I want to take back to the x-axis, just like normal, just like we did before. So that guy would be right there. Last time we subtracted 180 minus the angle we had, correct? But now I want to find this here. So in this case, I need to take 220 minus 180. Okay, my angle's past that, so I need to subtract 180 from this. Okay, what's 220 minus 180? 40. So 40 is my reference angle. So the cool part about this too is, someone's probably sitting here thinking, what's this reference angle do? Well, again, instead of having to worry about 135 degrees, the sine of 135 degrees is going to be the same as the sine of 45 degrees right here. Same way here, 220, maybe the cosine of 220 is going to be the same of 40 here. And we're just making numbers smaller so we can deal with them and make them easier. All right. Let's go to 3 and 4 here. 3 and 4, we're in the radian world now. Okay, these are radian measures. Just a reminder, in radians, because we probably don't know these as well yet, that's pi over 2, pi, and 3 pi over 2. Okay, so what quadrant would this be in? 3/4. You have 1, 1.5, right? These are my quadrants, quadrant angles. 3/4 is between 1/2 and 1, right? So this is going to be quadrant 2. Okay, be out here somewhere. That angle is 3 pi over 4. I'm worried about this angle now. So I'm going to take it, and I'm going to drop it down to the x-axis, standardizing my triangle. All right, so now I am above this axis. This is pi. This was 3 pi over 4. What do I need to do to find this angle? Subtract what? Subtract from pi, right? This is here. This is pi. This is 3/4 pi. So I need to take pi minus 3/4 pi. What's that going to be? It's pi over 4, yeah. All right. So 1 minus 3/4 is 1/4, or just pi over 4, making this angle here pi over 4. My reference angle for 3/4 pi. All right. Last one, 8 pi over 3. That's bigger than 2 pi, isn't it? 6 pi over 3 would be 2 pi. All right, so this is one where I went the whole way around, and then I got some left over, correct? So I need to subtract 2 pi from this. So 8 pi over 3. 2 pi would be 6 pi over 3. So I'm left with 2/3 pi. Okay, what quadrant would 2/3 pi be in? It'd be in the second one again, correct? Okay, 2 pi over 3. Right here, boom. Same kind of thing as last time. I'm going to have pi minus 2/3 pi. So what's 1 minus 2/3? 1/3, or pi over 3. So this angle would be pi over 3. Questions? All right, so before we get to the next section, are we all right with this? Yeah? Okay. Figure out where you are in reference to the x-axis, then figure out whether you have to subtract the quadrantal angle, or you have to subtract your angle from the quadrantal angle. All right? Now, so how are we going to use these? Well, we found the reference angle. Obviously, we did it for a reason. So here's the reason. We want to evaluate trig functions using the reference angle. So what you want to do first, you want to find the reference angle. Second, you want to find the value of the function. And then number 3, use the prefix sign to the function value. All right. Number 3 here, again, I took this straight from the book. This is where I differ a little bit from the book on this. Okay. So the book wants you to remember we did the all students take calculus to figure out which functions were positive and negative in each one. You know what I mean? I like better because we draw the triangle. I like drawing the triangle and then applying the negative signs on the triangle because I think that's easier to see. Okay? So I kind of take out step 3 because I want to draw these ones. So what we want to do, we want to make these into special triangles as much as possible. So let's recap our special triangles real quick. So we have the 45, 45, 90. Okay, 45 and 45 is the same as pi over 4. Okay, 45 degrees is pi over 4. What are my two legs in this triangle? So what's the lengths? 1 and 1, right? What's the hypotenuse? Square root 2, correct. Other special triangle is my 30, 60, 90. 60, 30. Okay. This one here, do we remember this one? Remember the side lengths on this guy? So root 3 and 1. Yep. So the leg that's touching the 30-degree angle is root 3. The other leg is 1. Hypotenuse is 2. Okay. If I want to um, put my radian measures in here too, this is going to be pi over 6. This guy is going to be pi over 3. Okay. So I just want to do these for reference because we're going to be using those again here. All right, so 135 degrees. Well, we just did 135 above, didn't we? Didn't we do this one? It's in quadrant 2, right? Quadrant 2, boom, here. 135. What's that angle that we create? What's our reference angle? 45, right? Okay. So now this is a 45, 45, 90 triangle. Everybody agree? Okay. So 45, 45, 90. My sides are 1, 1, and root 2. So I applied those. Now, based off of where we're at, is any of those signs negative? Well, if we remember, our hypotenuse or our radius is never going to be negative, correct? We only have to worry about these two sides. This guy's above the x-axis, so this one's positive, right? What about this guy? He's going to be negative because he's left. Okay, so we'll make that a negative. Now, I want to find the sine of 135 degrees. I found my reference angle. So now I'm looking at the sine of just this angle here. Okay. So the sine of that is going to be sine is what? Opposite over hypotenuse, correct. Okay, sine is opposite over hypotenuse. Opposite is 1. Hypotenuse is root 2. Can I leave it like that? No, I have to multiply by root 2 over root 2, right? So it's going to be equal to root 2 over 2. So root 2 over 2 would be the sine of 135 degrees. Now let's think for a second, make sure we didn't make any mistakes. We're quadrant 2. Is sine positive in quadrant 2? Yeah. All students take calc. A, S, T, C. So sine is positive in quadrant 2. We're good. Questions? All right, let's go to 225. So 225, what quadrant is that guy going to be in? Quadrant 3, correct. Did we just do this on both two? Did 220, okay. So we're close. All right, this guy's in quadrant 3. Boom, down in here. I got to take it back to my x-axis. To find my reference angle here, what do I need to do? Subtract what? Correct. subtract 180. So I have 225 minus 180, which is going to be what? 45. That makes my 45, 45, 90 triangle again, correct? 1, 1, root 2. Now, is anything negative there? Both ones are going to be negative, correct? All right, the horizontal one is left, so it's negative. The vertical one is down, so it is negative. All right, so now I need the tangent. The tangent of that angle, tangent is what over what? Opposite over adjacent, correct. Opposite is -1. Adjacent is -1, so therefore 1. So the tangent of 225 degrees would be 1. You guys with me so far? I don't think this is crazy. Honestly, I think the hardest part is setting up the reference angle. Okay. Last minute check. Again, quadrants A, S, T, C, tangent, and quadrant 3 should be positive. Our answer is positive. So we're good there. Okay, number 3, cosine of 4 pi over 3. So 4 pi over 3 is going to be in what quadrant? 4/3 is bigger than 1, correct? Quadrant 3, good. Give me in quadrant 3. Okay, 4 pi over 3. To find my reference angle, what do I need to do? Subtract what from 4/3? 4/3 pi. I subtract pi. Okay, so I'm going to have 4/3 is 1 and 1/3, correct? So 1 and 1/3 minus 1 is going to be 1/3. So this would be pi over 3. Okay, so then I'm looking at this as my special triangle, my 30, 60, 90, right? Pi over 3 is essentially my 60 degrees. So let's take this guy and set it up. My hypotenuse is going to be 2. This is my pi over 3. So the 1 is with that. Root 3 is going to be my opposite side. Now, what numbers are negative in this one? The 1 and the root 3, correct? There and there. Now I want to find the cosine of this. Cosine is going to be adjacent over hypotenuse. Excuse me. Adjacent over hypotenuse. So what's my adjacent side? -1. Hypotenuse is 2. I'm good. Cosine would be -1/2. Quadrant 3, cosine would be positive or negative? Negative, right? Okay, so we're good there. Last one. 11 pi over 6. So 11 pi over 6. First off, is that bigger than 2 pi? No, we're still good because it would be 12, right? So what quadrant is this guy going to be in? Quadrant 4, correct. It's almost the whole way around. Boom, boom. All right, so this is 11 pi over 6 to get there. So what's left for my reference angle? If I have 11, 6, I only have 1 6 left, right? Which would be pi over 6. Okay, pi over 6, the same as a 30-degree angle. Side's root 3. This guy's 1. This guy's 2. What sides are negative? Just the 1, correct? Now I want the secant. Secant is cosecant goes with sine, secant goes with cosine. Okay? So secant would be hypotenuse over adjacent. Okay? So this one here, hypotenuse over adjacent. What's my hypotenuse? 2. Adjacent is root 3. Can I leave it like that? Nope, I have to multiply by root 3 over root 3, giving me 2 root 3 over 3. So that would be my secant of 11 pi over 6. Questions? Anybody? Is that all right? Just takes a little bit of time. One thing I'm going to tell you with this, just kind of be patient. Take it slow. All right? Don't try to rush through it, because if you try to rush through it, then you're going to make mistakes, especially on like negative signs and those types of things.